This experiment aims to demonstrate the product of complete combustion of hydrocarbons. So in this setup, here's a small micro Bunsen burner which is attached to the natural gas, which is predominantly methane. So CH4, methane, an example of a hydrocarbon and alkane. Plentiful supply of oxygen in the room, therefore complete combustion. This funnel is designed to catch the products of combustion, and the products of combustion, because this apparatus is attached over at this side to a vacuum pump, the vacuum should cause anything that's produced over on the far side to be drawn in through this piece of tubing and through this piece of tubing, all the way through this piece of apparatus, which is called the U-tube, and all the way through this tubing. So in other words, the products of combustion from the hydrocarbon should be drawn all the way through all of that apparatus and then out to this vacuum system. Between the burning hydrocarbon and the exit, if you like, of this apparatus, there are two important reagents. So the first of those important reagents is inside this U-tube, and at the bottom here of this U-tube you can perhaps just about see that there's a white powder, and that white powder is anhydrous copper 2 sulfate powder. In this boiling tube over on this side, there's a colourless solution, and that colourless solution is lime water. To add to this piece of apparatus, what I'm going to do is just pop this ice bath underneath this U-tube apparatus here. So I'm just going to slide in the iced water around that U-tube just to help it to cool down, to try to condense that particular product of the combustion. I'm also going to start this vacuum pump from working by just turning on this tap, which just draws the air through the system like so. So hopefully you can see that we've got bubbling happening in that colourless lime water solution. So the final thing to do then is to set fire to the natural gas. So I shall move the micro burner just out from underneath the apparatus, take a match, make sure the air hole's closed for now, which it is, light the micro burner. So I've lit the micro burner. The next thing I will do is just carefully twist the air hole so that we ensure complete combustion, and I shall pop the micro burner under the funnel. You can perhaps catch actually some condensation on the side of this cold funnel. It's quite cold in here today, so that's an interesting observation, and up here and in here, and then let that carry on. That's going to need to run for a few minutes before we see any notable observations, so we'll let that run and we'll come back in a few minutes time. This has been running for a few minutes now, and I'm going to just turn off the little micro burner at the gas tap. So I'll just turn it off and let's have a look at what it looks like. So you can perhaps see up here where the tubing is reasonably cool, it looks as if there's a colourless substance, a colourless liquid being condensed on the side of that. Coming across then we've got the U-tube. I'll just come around to the side where I can reach properly, and let's remove the ice bath from in front of that U-tube now and see what's happened, if anything. Oh yeah, so move that out of the way, be able to see it. To the anhydrous copper 2 sulfate, hopefully you can pick up that this has changed colour, and also notice inside here, that's condensation, and it's definitely on the inside of that tubing because it's not moving as I'm running my finger over that tubing. So we've definitely got some blue copper 2 sulfate there. Moving across then to the lime water, and hopefully you can make the observation in the lime water that that's changed. So linking all that together, you can perhaps now go back to the theory and think about which two products must have been produced by the complete combustion of this fuel, as evidenced by two different experimental observations, one involving the copper 2 sulfate and the other involving the lime water.